special angles. We got special angle of 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now let's start with the first triangle. Now the first triangle is an isosceles triangle. This side right here is equal to this side. Now what you need to remember is these equal sides are equal to 1. Now that 1 that they both are equal to, you just add it up, you say 1 plus 1, and it gives you 2. That 2, you just put it into a square bracket. So it's 1 plus 1, and it gives you 2, and you just put a radical sign on top of that 2. Now, since this is an isosceles triangle, these two sides, since they're both equal, they have to subtend equal angles. These angles right here, they're equal. It's gotta have equal angles. Since this is an isosceles triangle, they gotta have the same angle. Since this already is 90 degrees, these two angles both have to add up to 90 degrees as well, so that the sum of all angles in this triangle have to add up to 180. When they want us to determine sine 45 degrees, you can use this angle, you can also use this angle. When you use this angle, it's still going to be opposite side over the hypotenuse side, which is going to give you 1 over square root of 2. Your calculator is going to give you the answer of square root of 2 over 2 because it was already rationalized. When you rationalize the denominator, you multiply by the denominator on top and also at the bottom. The main point is to make the denominator not to have the square bracket. So square root of 2 multiplied by square root of 2, that will give us square root of 4, and square root of 4 is 2. 1 multiplied by square root of 2, that will give us square root of 2. Sine 45 degrees is equal to square root of 2 divided by 2. You can even determine sine 45 by using this angle right here. The second triangle is the one with 60 degrees and 30 degrees. With this one, all you have to remember is this side right here still has 1 like the previous triangle. You still have to put 1 right there. You still go with that 1, you still go with this 2. You're going to add this 1, and you're also going to add this 2. 1 plus 2, that gives you 3. The highest number deserves a radical sign. Now, always remember that the square root of 3 goes together with 30-degree angle. They go together. Since I already have 90 degrees and I already have 30, the only angle that's left is 60. We can determine sine 30 degrees. We can determine cos 60 degrees. Sine 30 degrees has to give us what? 1 over 2. Opposite over hypotenuse. Cos 60 degrees is adjacent over hypotenuse, which is still 1 over 2. So that's the reason why sine 30 degrees and cos 60 degrees are equal. What about sine 60 degrees and cos 30 degrees? Believe you me, they're both equal as well, and they will give us square root of 3 over 2. So sine 60 degrees is opposite, which is square root of 3 divided by 2, which is the hypotenuse, and then cos 30 degrees adjacent, which is square root of 3 divided by 2. The last triangle that has two 90-degree angles. We have the first 90-degree angle, we have the second 90-degree angle. Now, since the sum of all angles of a triangle have to add up to 180, 90 plus 90, it gives us 180. So the remaining angle has to be 0 degrees. Yeah, this is a very strange triangle, but believe you me, it exists. The sides that are facing or that are opposite to these 90-degree angles, they're both equal to 1. This 90-degree angle is pointing at this side right here, and that side right here is equal to 1 unit. This 90-degree angle is pointing at this side right here, and it's also equal to 1. The side that's opposite to the 0-degree angle is is equal to 0. If this side is 0, why does it exist? If this angle is 0 degrees, why is it so open? Why isn't it like this? A lot of people may have a lot of theories about this, but hey, since we're mathematicians, we make anything possible, and we just make everything work in our favor. All of these angles, they're what we call special angles. If we had to determine sine 90 degrees and cos 0 degrees, if we had to work out sine 90 degrees, the opposite side of this 90 degrees is this side right here. That's the opposite side. So that was going to be 1 divided by the hypotenuse. This is still the hypotenuse, which is 1. So the answer for sine 90 degrees is 1. When we have two different trig functions, and when we add their angles, end up giving us 90 degrees, those trig ratios are equal. Let's check that here. Cos 0 degrees is adjacent, which is 1, which is x, divided by hypotenuse, which is 1 as well. So we still get 1. Let's check cos 90 degrees and sine 0 degrees. Cos 90 degrees, this is the adjacent side right here, which is 0, right? 0 divided by the hypotenuse, which is 1. So in the end, that's going to give us 0. Sine 0 degrees, that's the opposite side over the hypotenuse, which is 1. So it's still going to be 0 divided by 1, which is 0. You can check them on your calculator. Those are acute special angles. Special angles that are greater than 90. If you add 30 degrees to 90 degrees, what do you get? You get 120. 120 is a special angle. If you add 45 degrees to 90, what do you get? I'm pretty sure you get 135, right? Any special angle you add to 90, you're going to get an obtuse angle, but that obtuse angle, I'm pretty sure, and I'm going to tell you right now, that's a special angle right there. I'll see you in the next video. Stay tuned.